Hello friends, welcome to my channel. Let's have a look at problem 2333 together. Minimum sum of squared difference. So in this video, we're going to share a method that is similar in idea to bucket sort. Here the problem actually is to minimize the L2 distance of two integer vectors. So I will not read through the problem statement here. We'll directly go to the analysis. First, the method here is shrink the absolute difference from large to small. So this is similar to the idea of bucket sort in the sense that we sort of sort the absolute difference from large to small. So the idea is that we count the frequency of the absolute differences, and then we shrink them from large to small. And this method or idea is based on the following observation. So the crux of this problem is the absolute difference. The reason is that doing increment by +1 or -1 in nums 1 is equivalent to doing increment by the reverse, that is -1 and +1 in nums 2. So here our goal is to minimize the L2 distance of the two vectors, that is to shrink the absolute difference. So we don't need to consider the increment details. So we just need to be aware that there is at most k1 plus k2 times of such operations we could do. So with that said, let's walk through an example. So this example is a variant of example 1. The reason is that example 1 is trivial because of the fact k1 equals k2 equals 0. So we change here k1 equals 2 and k2 equals 3. So the overall operation we can do is 2 plus 3, that is 5. So we want to first count the absolute difference at their frequencies. So in the initial bucket, so we have 1 minus 5, 4 minus 8, 10 minus 6 are all having absolute value 4. So the absolute difference 4 have 3 counts, and 12 minus 9 is 3, so it has 1 count. So actually for this problem, the final bucket is given here. So we can add the corresponding squares and counts to get the final result. So let's look at the procedure. So here we want first shrink the difference, that is 4, by the available actions. So we have 5 in total. So here we have 4. We have 3 of the difference 4. So we can shrink each of them by 1. So we shrink that. We change this difference 4 to be 3 by shrinking 1. So its frequency is decrement by 3, tends to be 4. The frequency is 3 minus 3 is 0. And accordingly, the 3 actually increased its count by the 3, resulted from decrementing the 4. That is 1 plus 3 is 4. So the remaining operations we can do is 5 minus 3 is 2. So now with the current k and the current bucket, so we want to shrink the difference 3, right? So here we have 4 counts of this difference 3. However, we only have 2 operations, so we can shrink 2 of the 4 difference 3, right? So if we shrink 2 of them, so we get 2 frequency decrement. So we get the 3 has the frequency 1 plus 3 minus 2, and we also produces 2 counts of difference 2, that is 3 minus 1. So we have 2 and 2. So in this situation, we remain 0 available operations. So that's the end. So then we get the final result. For example, for the gap 3, so we have 2 counts. So its contribution to the final sum is 3 squared times 2, right? So here we have the gap 2 it has two counts. So its contribution to the final sum is 2 squared times 2. So 8 plus 18 is 26. So this is the result for this specific example. So here, before we write the code, we want to make some remark. So the critical point here is that, so we need to do the update from large absolute difference or large bucket key to smaller absolute difference or smaller bucket key. So the reason is that we shrink the larger bucket key by 1. Then next step, we're automatically taking care of the smaller bucket key produced from the previous steps. The second one is that the bucket key 0, it's already in optimal state, so we do not need any further operations. So with that said, let's look at the code. We're going to translate the above observation and idea into code. First, we want to track the length of the corresponding vector, so we can do it using nums1 or nums2, both are okay. Then we're going to track the absolute difference. So here it's basically a list comprehension. So for x minus y, for xy in zip, nums1 and nums2. Then we're going to track the largest difference to determine the number of buckets. That's max abs diff. Then we're going to initialize the bucket. So here I'm going to use a dictionary for the ease of update and check. So the buckets is going to be a dictionary comprehension. So originally this count all are 0. So for I in range, so 0 up to m plus 1. So ending at m. So that's the initial state for the bucket when we do the initialization. Now let's count the corresponding frequencies of this differences in the absolute difference list. So for delt in abs diff, then we're going to update the bucket corresponding to this k by 1. So that way we finish the initialization using the information in this absolute difference list. So now we're going to do the procedure specified above. So the total number operation is nothing but k equals k1 plus k2. And then we're going to do the update from the large to small. So for I in range, say m, so we're going to end at 1, because if a bucket is 0 corresponding to 0 difference, that's already the optimal state. So it decremented by 1. So here let me make a remark. So this is crucial. Then we're going to check if the buckets with absolute difference I is greater than 0. So if its frequency is equal to 0, so it means no such difference. So then we're going to make a temporary variable, which is a number of this specific gap I we can change or shrink. So that should be the minimum of bucket counts, buckets I, and the available operations key, right? So with this temp information retrieved, we can do the operations. So we are going to decrement this guy by temp. Then accordingly, we produced a smaller gap, that is I minus 1. So we're going to increment this gap by the count temp exactly. Then the available operations we can do actually is decremented by this temp. So that's all the operations we need to do. Due to the order we do this operation, in other words, from large to small. So we automatically taking care of the new buckets produced in the previous step. Then we're going to return the result. The result is nothing but a sum, the L2 distance square. So it's the count times diff square, right? So for diff and count in bucket items. So that's the full code based on the above analysis. So let's do a special case check first. This is for the example we cooked up, so we can actually change it to be 0, 0 to test for example 1. So this gives 15. So this is slightly different from example 1. Let's change it to be 1, 1 for a test for example 2. Let's see, 1, 1. 43, same as this one. So now let's do a generic case check. Oh yeah, it passes the generic case. So I guess for this problem, and this about it for this solution. So here is a follow-up question. So the question is that because we mimicking the idea of bucket sort. So actually, the heap data structure also comes natural for this problem. So the question is, can you solve this problem using heap? So using the maximum heap. See, that's it for this problem. Thank you very much.